Hello, 108 class. Mr. McHugh here with you. We are ready to kick off section 9.5. We are going to do some graphing of parabolas of the quadratic equation, which are going to produce parabolas. Page 1, we're going to get an intro and get started here. And if you have your books or if you got your e-books, turn to page 531. That's where this starts. I just want you to look at that real quick. I want you to see in that lower bottom of page 531, they show XY and a parabola, and it looks like this, but I want you to notice here real quick, all they ever do in this book is they show an XY table. And they say X and Y, and what they don't do is the nitty-gritty, what I call this an expanded XY table. And so let me back up for a second, but I want you to see the significance of taking the extra time to do the expanded XY table so you really understand the nitty-gritty dirty work as to how you get input, process, output. Okay, now f of x is a function. Remember, it could be a y equals, and the quadratic equation is ax squared plus bx plus c. Okay, and again, for the umpteenth time, you guys know it's a quadratic because you got to have that x squared in there. And so we're going to start graphing here, and we're going to start with the parent graph. And what we're going to do is, let's just assume that c is 0 and b is 0. What would happen to that? They would all drop out, and and if you let a equal 1, we're trying to make the simplest quadratic equation, which is called the parent. F of x or y equals x squared is how we're going to start this. Okay, and so I want you to take advantage of this chapter, this section 9.5, and we're going to cover 8 pages of notes here and 10 pages of notes on 9.6. The graphs, study them, study the expanded XY tables, make sure you understand and you see what happens when you take something. Oops, where's my pen at? When you take a value for x input, you put it into the function, you square a number, you get the output. Input, process, output. That is the definition of what a function is all about. If I put a -2 into the function, -2 squared is a +4. So this is only what the book shows. They show -2, 4. Where'd that come from? Okay, input, process, output, and then you start to plot them on a graph. Pick -1. -1 squared is a +1. Input, process, output. -1, 1. Look what happens when you put 0. And remember that when 0 is squared, the output is 0. And so you've got the origin there at 0, 0, and 1 squared is 1, so 1, 1, and finally 2 squared is 2, 2. And if I would do 3, I would have what? 3 input, 3 squared equals 9. That order pair is 3, 9. Now I'm out of room out here, of course, but I want you to see, and if I had a -3, what would it be? It'd be sitting out here roughly. Notice how quickly parabolas, they start up high in this case because it's a +1. The coefficient A is a positive, so they come up and they start down and they go up very quickly. I just find that fascinating that squaring, whether you put a negative number or a positive number, you square, you always get a positive. Therefore, these graphs all are up for right now to start with, on above the x-axis here for now. Okay, so that's the idea. You can see the quadratic function here. There are many uses for this. I've talked about in class. I get into how I worked for the Navy Aegis project, and I was indirectly involved with it. But ballistic missiles go up and they come down like this, and we had Aegis cruisers that after the Iraq War, Scud missiles shot by Iraq, we were able to shoot down and intercept missiles here. So I usually give a big spiel about this, but these parabolas, if we could track them with the radar and get this parabola, and get the quadratic equation that matched that parameter, then we were able to predict the intercept of these ballistic missiles. So there are many practical applications. So as you go through this chapter, you go, why am I learning about parabolas? They are used, satellite dishes, car headlights are using them, cable ballistic missiles. So they've got it's good to understand how they work. Okay, so that's y equals x squared. Now let's keep moving on here and study that expanded XY table like I mentioned here. Now, objective 2, what we're going to do now is what happens if instead of having just x squared, what if we had, again, we got, y equals, I'm writing this again, ax squared plus bx plus c. What happens if b would be a 0, the b or the x term would cancel out, and you'd be left with a constant, which I don't know why they don't put a c here, but they use a k. And so what will happen to the graph? Okay, so I want you to study these. Again, I don't know, I think the book shows these examples here. I did example 1. This is on page 532. They do not show the expanded XY table. Make sure you understand where this is coming from. So what happens if it's minus 2? Okay, what's going to happen to the graph? Pick values for x input, stick them into the equation, do the process, and get the output. Okay, now I don't think I'm going to sit here and say every single example here for you, but look at negative 2 squared would be what? 4 minus 2 is a 2, ordered pair negative 2 comma 2. Okay, look what happens here. Let's jump down. Oh, and by the way, I forgot to do this up here. Look at the pairings. I forgot to show this. This is called the vertex right here. When we put 0 in for x, 0 squared is 0 minus 2. There, look at that big drop. There's where the whole graph slides 2 units down vertically. So the vertex is at 0 comma negative 2. This is called the vertex. That's the lowest or the highest point of a parabola. And let me just scroll up here for a minute. I wanted to highlight that here again. Look at the pairings here. Negative 2, positive 2. The output, 4 and 4. That produces that bowl shape. This is the symmetry that's produced. Okay, again, I just find this fascinating to think about. There is the vertex. That again right here at 0 comma 0, the origin is the lowest point on that parent graph. Okay, now if I scroll back down, we are looking at the graphs and seeing that what you learn real quickly is that the k or the c constant, whatever that number is, it shifts the whole parent graph up that many units or down that many units vertically. So if I would write y equals x squared plus 2, I would turn around. I would come up here at 0 comma 0. There's the parent graph. The vertex would move up 2 units, and the graph would look like this. Okay. I think next page I do a comparison of that to help you out. So that's the idea here. So okay, so I'm going to stop yakking here so you're getting the idea. Make sure you understand. I'm sorry I keep repeating this over and over again, but you got to understand expanded XY tables. Use them. They're powerful to help you out. Many students only see the XY table and they get lost because they don't understand how the book got all these numbers. Input, process, output. Okay, Mr. McHugh, that's good enough for now. Page 1, we got a lot to do. So I'll catch you on page 2 and we'll keep working on this. Okay, bye.